to 50 milliseconds. So just the sheer amount of data, we started scratching our heads and thought, okay, there has to be a better way of processing this data. So we formed OneTech and specifically MicroAI to process that data as locally as possible. Since then have certainly won some big names in the space, ranging from large telcos, big agriculture firms, tier 1 automotive manufacturers. So certainly exciting times here at OneTech. Also winning a lot of awards, everything from IoT innovations and AI breakthrough awards and whatnot. Really kind of diving into this. So what do we do here at OneTech? Ultimately, it's providing device and equipment OEMs the intelligence at the endpoint itself. So early days at OneTech, MicroAI was primarily living on MPU-based devices, CPU-based devices, and since then have been able to drastically shrink that footprint and computing resource requirement to successfully run directly there in that MCU environment. In doing so, we're able to process that data at its originating source to provide insight to how that equipment or device is running. We'll take a quick look later on at how this also can play in the security space as well. Instead of looking at physical sensor values, so instead of temperature and vibration and all of those good data points, actually looking internal to IT assets. So think of CPU usage, memory usage, data packet size, frequency, to form a behavioral profile for really endpoint threat detection. So kind of two different ways that MicroAI is deployed. As mentioned earlier, we can deploy these, customer-facing end-to-end solutions, but again, core competency is really our MicroAI product. Again, stressing the ability to train directly there at the endpoint. So a couple of different buckets that we work with, working with a lot of the large silicon manufacturers to become embedded directly into their hardware architecture from origination. And then those chips that we become embedded on are then put into the smart equipment. So a lot of equipment is instrumented today, but may or may not have the level of intelligence of necessarily processing the data, looking for those signs of failure, general anomalies that are happening with those machines. Then, of course, right-hand side here, the large brownfield space of legacy equipment out in the field that is not instrumented. So we have a lot of deployments in the space of going in, placing over-the-top sensors and hardware on those various assets to then gather the insight, process the data, and ship out that processed data. So really from industrial to commercial to consumer, everything from construction sites, oil and gas sites, down to smart grids, all the way to home appliances and smart meters. Wide array of various applicable use cases for this type of technology. But before I go there, let me just give a quick example of why we believe training at the endpoint is so relevant and why the industry should be moving this direction. In typical AI deployments, you would gather a lot of historical data, take it to a GPU-based environment or cloud environment, form a model, and then push that model down to the assets. So let's say we did that with smart water meters. And let's say that Shannon and I are neighbors and we both have smart water meters. Let's say that she has a pool and lavish landscape, and so she's using quite a bit of water. And maybe I'm the neighbor that just doesn't water their lawn at all. So I'm not using much water at all. In that instance, with that cloud-based model, the AI would say, Shannon, you're using way too much water, or Chris, you're not using enough water at all, versus training in that local environment, we get a much more accurate and precise understanding of what is true normal for that local deployment. Similarly with a robotic arm, right? So you can have a Phonic 210F robot. One may be doing MIG welding, the other is a material handler. So just because it is the exact same make and model of machine, training in that same region, that same geographic location, and along with the job that it's actually performing, again, a much more precise understanding of what is true norm for that particular asset. So talking about embedded AI, again, kind of our flagship product there. As part of our offering, we have a connectivity arm. So for these deployments, instead of needing to stitch together a lot of these puzzle pieces, one of those being connectivity, we have various cellular carriers tied into the platform, so you can fire up your cellular-based plans directly from the platform. Similarly with cloud, so we're cloud agnostic, can spin up instances in AWS or Azure. We have a handful of data centers that we manage as well here here in the States and also in Australia. Ultimately, allowing for these puzzle pieces to come together for that AI-driven insight. So we have a lot of more so templatized or productized approaches. So if it's a manufacturing facility, we have the foundational elements for, what KPIs are most important, whether it's, unexpected downtime events or OEE. So those various dashboards and workflows already in place to allow for rapid time to market. It's going a bit more in detail into that platform setup. So we're agnostic to the device, agnostic to the data that's being fed. So you can go in and set up the device profile. So if it's, let's say, going on a vehicle, you may have specific data points, or if it's going on a pump jack in West Texas, you may have a completely different set of data points that are being fed into the system. So first step would be to define those various device profiles, spin up your instance in the cloud, select your connectivity, embed MicroAI into those devices, configure your events and notifications. So whenever those signs of failure or general anomalies are occurring with those assets, what needs to happen, and then of course all of the visualization tools in place. And just taking that a little step further, more down into the technical weeds, if you will, as far as the connectivity, whether it is cellular-based devices, BLE, LoRa, we're supporting a lot of CAT-M and NB IoT cellular-based deployments as well. And with the workflow arm, right? So with IoT deployments, it's only as valuable as what the action is that actually is triggered. So being able to have those business rules and business logic in place to track whenever a ticket is opened, what actually, what steps need to take place to remediate the issue that's taking place. Back to MicroAI, we have a handful of different flavors. So we have a flavor written in C, one in Java, Golang, and one in Python as well. The events and notifications, they can be API calls, various thresholds. So let's say we detect just a small blip in deviation, let's say 1.5, 2 standard deviations outside of the normal parameters. We may just log that as a watch event and see if there's any pattern or correlation to when those events occur. If it's a severe event, then we may trigger a critical alarm, call an API to open up a work order, etc. And then with the visualization tool, as mentioned, we have kind of those CAN dashboards built out for various industries, but they're all modifiable in a drag and drop instance. So similar to Tableau, Power BI, you name it, very similar visualization tool built into the platform as well. So let's jump into some case studies here. So far, so good. Hopefully I'm not putting people to sleep. Any questions? All right, we'll keep rocking and rolling. So, high level use case, and we'll dive in. Very common that OEMs or asset owners have little insight to the actual health, performance, utilization, behavior of the equipment that's deployed out into the field. So we bring in MicroAI to then process data out in the field for that asset, and then trigger events based on those signs of failure. So real world example of this, work with again, tier 1 automotive manufacturer, many different facilities. This one in particular is an automotive body assembly line. Lots of MIG welding happening here. They were running at about 50% OEE, or overall equipment effectiveness. This was really caused by two main items. One, a lot of unexpected downtime. Two was quality of weld, or rather poor quality of weld, that caused for a lot of manual rework. So our process here was first to understand the intelligence that existed in the ecosystem already. So we tied into their manufacturing execution system, tied into the various controllers, PLC tags, to see what level of intelligence they currently have. By doing so, ran a gap analysis and deployed over-the-top sensors on the equipment. Some of the equipment also had embedded sensors that we were able to tie into. This actually all ran on-premise, so no cellular connection here. Brought that data together, processed that data, and then the output from MicroAI is shipped to two different applications. Mobile application primarily used by the technicians and operators out on the shop floor. So if there is some sort of critical alert, the tech gets a push notification. They can go in and see the data snapshot that actually triggered that alert. They can also see a historical log of any previous events or notifications that have come from that machine as a roadmap item, or something that's in our R&D lab right now. We're actually tying into video feeds. So whenever that critical alert or sign of failure, trending towards a failure occurs, we're actually taking it just a 5 to 15 second video of that particular asset, embedding that into that packet that's sent out for the technician to understand exactly what's going on there. On the right-hand side is more so your desktop application. It's where the work order and dispatch management takes place, along with your enterprise asset management and asset performance management. So think of being able to see global facilities, then drawing down into particular plants, lines, stations, substations, all the way down to the asset and operator level. So after about 90 days or so, we're able to get a drastic increase in OEE for this particular line. Really, the main reason here, one, reduction in the unexpected downtime by identifying those signs of failure prior to the entire line coming down. So if one of these robots goes down, the entire line came to a grinding halt. Secondly was that quality of weld. So with these MIG welders, after they make a hit, that welding tip actually continues to wear down. And to produce the same quality of weld in the same cycle time, you actually need to push more current or voltage to that welder. So first phase, we're simply sending a notification. Technician or operator would go to the HMI, adjust the voltage to continue on with that same level of quality. Now we're actually tying directly back to that welder controller to increase the voltage whenever it is deteriorating. Continuing forward, so it's quite shocking how we talk to a lot of these large manufacturers, and it's really just run till failure. So certainly taking the some of these possibly some might say outdated processes from reactive and planned maintenance, much more so to the predictive side of the house. And so to really classify as predictive, we look at the trends and look at the volatility in those different data points, and really we can predict what that mean time to failure is for a particular asset. So if we start to see trends, towards a critical threshold, we can say within a given range, maybe it could be 15 minutes, it could be 15 hours of service time, that we do expect within inside that time frame there is going to be an issue. So a work order to be generated and opened for the planned downtime, whether that's a break, a lunch, or simply a different planned downtime for that particular line and station. Moving on to mining. So mining is really unique as connectivity is not always available, right? So this is where MicroAI tends to shine, is being able to process data and keep that data in that local environment without connectivity, and it's really store and forward. So as these pieces of equipment are outside of network connectivity, being able to process all of that data, store those events, and then as it then returns to network connectivity, being able to transmit those back up to the environment for consumption. Moving forward to automotive, so lots and lots of data can be generated from a vehicle, and transmitting all of that data off of the vehicle through, let's say, a cellular connection up into a cloud for processing gets extremely costly. And gigabytes of data can be generated every hour from a vehicle if all the sensors are turned on. So by, again, training, keeping that data local to that environment, and only sending out those pertinent and actionable items, certainly reduces a lot of cost for the OEMs of automotive. Another quick use case here in the telco space. So, we've looked a lot at industrial assets, now auto, now moving more over to network infrastructure. Really by processing log data, we're able to pick up some of the those early signs of failure. Could just be a simple memory issue, or could be a much more complex issue that is forming in the background. So by monitoring that network equipment and taking corrective action prior to any unexpected downtime occurs, obviously has a lot of benefits to those network operators. So let's jump into the technology. Again, I'll pause real quick. Everyone's still there?
It's still here. I have questions. So I'm again trying to think about the data that you're sending back and forth, right? So a lot of times with IoT data, we would send data every time, not from a time series perspective, we don't send every value. We would only send data that was when the value changed. Are you guys taking it like a step further? Is that what you're saying, where you're not just even sending the data values, you're just sending the outcomes?
It's really anything that, well, and I'll back up some. So we form that behavioral profile for the asset. And shortly I'll walk us through that process of our training method. But each asset has its own behavioral profile, and it's multidimensional. So each one of those data points that's feeding in is correlated, right? So as an example, as RPMs go up, we would expect maybe bearing temperatures to go up slightly within a given range. So those upper and lower bounds are formed for each one of those data inputs. And if those bounds are ever exceeded, that's whenever we would trigger that data send. Now this is configurable, right? You may want to take a data snapshot, let's say a maximum, minimum, median, or average value on a certain cadence. But if you're certainly trying to limit the amount of data that you're sending, you can have it configured to only alert you whenever there are certain actionable items that need to be acted upon. It sounded kind of odd, but only sending out to the those events whenever there is something abnormal occurring.
So I think that's something that's very different from the other solutions that I have seen, in that they would have to send all the data values back to then have the logic up in the cloud, right, to determine if it was in and out of those bounds. So this is different in the fact that you're down at the edge, you're making that decision at the edge, and then you're only sending back when you're outside of a normal condition. So you're doing an alert. So that's important. I mean, because I think about the cost, I think that's where you're saying the cost of the cell service and the amount of data you send, or even more importantly, let's say you're out in a very remote spot, out in the wild, or a stochastic environment in which there are no cells. I mean, you could think of a marine application, you're out and then everybody has to use satellite. So from a satellite perspective, I would think being able to have that AI down at the edge would be very important, because satellite communication is so expensive.
Right.
Absolutely.
Chris, I have a question. So the calculations for what Shannon just talked about, does it mean that you have to have a powerful computer or a small device or a microchip installed actually at the machine itself?
No, so that's a great question. 2 years ago, yes, we need to have some sort of, well, 2 years ago, a Raspberry Pi Zero was kind of the needed level of compute power, which is actually pretty significant. Today, we're now running on the likes of ESP32s, Cortex M3 ARM-based processors. So we're talking about, $1, $2 compute devices that are able to not only run the AI, but also train that model, which obviously training is the most resource extensive or intensive piece there. So certainly do not need expensive compute, an expensive compute environment
to run those devices to communicate outside, right? Regardless whether at least, I mean, in those areas where the outside world's available, or a landline or something, at least pick the box out and bring it to a landline, right? So that
right, you would need some sort of
out.
Yeah, you would need some sort of host device to obviously do the data transmission, right? Whether that's a cellular module or it's wired in, what have you. But the actual compute can be done on very inexpensive devices.
Good. One more question, Chris. PLCs, you mentioned PLCs a little while ago, and I know I've worked with PLCs a lot. I used to work with Ecolab, and I've done some amazing projects with them. And PLCs differ from machine to machine, company to company, their languages, their access, everything differs. So for example, if obviously CAT manufactures their own devices and stuff, but if it was a outside manufactured device, the language would differ. How do you connect with these devices themselves, the PLCs? And PLCs themselves also have some algorithms built in, or some alert monitoring built into them at some point of time. So how does that work together with this technology?
Yeah, absolutely. So we have a library of various drivers that are a part of the platform. So, whether it's Siemens or Allen Bradley's, we have kind of, what's that?
Backoffs?
Possibly.
Backoffs. They're based out of Germany, backoffs.
Yeah. So, well, I don't have them all off the top of my head, but we do have a handful, or rather quite extensive library of various drivers a part of the platform that I went through. And then, of course, we're stumbling into PLC models that we haven't seen before. So depending on, when we do run into those scenarios, of course, we may leverage the likes of Kepler or something similar to download those drivers.
Great. Thank you.
Absolutely. Cool. So let's keep rocking and rolling here. Let's dive into the technology. So I think I mentioned this before. Ultimately, we're agnostic to the sensor data. So whether it's accelerometer, current voltage, doing a lot with acoustic emission sensors today. So think of little microphones that are listening to moving parts. Or doing a lot with infrared sensors and whatnot. Ultimately, agnostic to those sensor values. So really, first layer is simply bringing that data all together. So fusing that data in this first layer, internally we call it Xcode. It's really where the pre-processing is done and that feature engineering is done for those various data inputs. Once the data is being fed in, then you start training that model. The length of model training is really dependent on the asset and its cycle, a normal cycle for that asset. So on one extreme example of that, you may have a robotic arm that performs the same task every 7 seconds. So in a matter of a couple of minutes, you have a pretty good model that's formed. On an extreme other end, we've worked with a water treatment facility that has a backwash pump that turns on once every 24 hours for 7 minutes. So in that instance, we had to train over multiple weeks. So the model understood that it was completely normal for this to sit dormant for 23 hours and 53 minutes. So that training period length is configurable. Once the model is trained, then switches over to running the inferencing and producing the outputs. Again, agnostic to where those outputs go. So any existing IT tools, whether it's CMMS systems, manufacturing execution systems, any data visualization tools, workflow management tools, anything that's already in place can certainly consume the data. As I showed earlier, we also have some supporting pieces of the puzzle here too. So that's kind of the straightforward path. We also quite often, as we just spoke about, tie into that controller data. So let's say that I have my dishwasher here at the house, sensored up. So I'm looking at current and voltage, may look at the temperature and vibrations of the motor. So I trained that model, and when the model was trained, it was in just normal, just the normal wash mode. And then whenever I switch it over to, let's say, pots and pans and kind of that more intense wash cycle, that original model is going to say, hey, something's way off here. So by tying into those controllers, we're able to understand the specific job that machine is running. And if there is a job ID, style ID, that is being fed in that we have not seen before, you can automatically have it switch over to training mode to form that new model for that new job or style ID that's run through that particular asset. So this over here is really just providing contextual data to the model itself. Again, ultimately, it's a MicroAI is a multi-dimensional behavior analysis algorithm. So what that means is we're taking data inputs from many different sources, looking at how they correlate, how they move with one another, and ultimately form that behavioral profile for that asset. And when that behavior differs from the norm, that's when the actions are triggered.
So are you saying that you can take multiple inputs? It's not just one parameter you're looking at to look at the highs and the lows and what's normal. You're looking at multiple parameters. It can be quite complicated.
Oh yeah, yeah.
Okay.
We have some assets that have like individual machines that have hundreds of different inputs, right? So there's yes, it certainly can consume many different data points for a single asset. Some of those may be over-the-top sensors, some are embedded sensors, some are coming through those PLC tags, all of which we're looking at how they move with one another. Again, so let's say that as RPMs of the machine go up, temperatures, pressures, vibration are going to probably go up as well, but it's different rates, right? And of course, there's going to be a maximum and minimum expected value for each one of those. So they're all moving in conjunction with each other. It doesn't have to be that we're looking at many different values for a particular asset. It could be just a simple light bulb, looking at its normal energy usage. So we could simply just look at its current or voltage consumption. And typically when a light bulb starts using about 2.5 standard deviations more energy, that is a sign of failure. So think of the process of a smart streetlight deployment. Instead of someone needing to look through just a ton of data to say, okay, now here's all the energy that's being used, which one of these stands out? More so, just automate the process. So whenever it starts using, a light bulb starts nearing that 2.5 standard deviation mark on energy usage, call an API, check for to see if that bulb is in inventory. If so, call another API to open up the work order, truck rolls, and you can essentially automate most of that process. So, and it's all by just a single data point.
Jeff, I have one more question. Sorry, guys. This is a very interesting topic because I worked with so many PLCs and so many AI systems with Ecolab. Does your system also have connectivity on the ground, meaning at the asset itself, for alerts and alarms that typically should be known right away? So, for example, something's really going on with that arm. Somebody who's connected with a small handheld micro device or a phone or whatever, right there, obviously. Because you can't take the data in all instances out to the world, does it connect like that to give out alarms and alerts?
Of course. So the majority of our large tier 1 manufacturing deployments are 100% on-premise. So they're living in the intranet there. And so those handheld computers and whatnot are tied into the system. So instead of making that round trip, certainly reduce latency. So whenever those critical alerts are firing off, those decision rules can be in place. We can look at, okay, who's the tech that's on duty that's certified for this particular machine. Let's say it's a CNC machine and there's only a handful here at the plant, and can push that alert directly to that technician. So yeah, long-winded way of saying certainly.
Right, and you would apart from having those $1, $2 machines, you would need a central system at the plant itself that would take all of the data from the different machines and alert. And or you can have a singular alert system for that single machine itself also.
You got it. And there's a lot of different ways to skin the cat, right? So each individual asset can have its own hub, if you will, right? That's processing data for that unique asset. You can scale up that device to where, let's say, each station may have 15, 20 different assets that are feeding into that central hub. But whether you do either one of those, yes, typically there is kind of that central hub for the facility that is aggregating, and that's typically housing the visualization tool, those the events, the notifications, and firing those off.
Great. Thank you.
Absolutely. Anyone else have any quick questions here or long questions?
I got a question, Chris. This is Sham here. I know I'm not sure if you have a slide that actually kind of explains how your overall system looks like. I'm just assuming that this is like you got a hardware and you have this MicroAI and endpoint AI running on that particular hardware. And just trying to get a feel of how that actual hardware software combination looks like, and how you are actually connecting it to a particular device that you are trying to monitor. Do you have any slide like that, or is it something available on your website?
I do not know if I have one in this slideshow. Let's, Brad, maybe we just exchange contact information there. We have product sheets and that go in extreme detail on how this is all architected. So okay. It may make sense for us to shoot over one of those product sheets.
Sure. That's
Yeah.
sure. Yeah.
Absolutely. Absolutely. All right, we'll keep on moving here. So of course, again, endpoint AI, embedded AI is what I've been speaking about a lot here as well. Of course, we can run at the edge as well. And then the output, again, can go to our platform, can be consumed by, any of these logos listed out here. We also consume data from a lot of these logos here, all the way to ERP systems and sales, forecasting tools. And where that comes into play is now that we know, how facilities are running, and if there is a large order that comes in for a manufacturing facility to run a particular job, we can look at the historical data to understand, how did the line run whenever we ran this particular job. And if it ran poorly, were there any other lines in the area that ran that job that had a higher productivity rate, higher OEE rate? So it really becomes a quite extensive, data aggregation tool for multiple data sources. So moving forward here, a bit of a recap of what I've covered earlier, but really, raw data fed into that local device. In this instance, it's an STM32 Cortex M4 based device, pulling in that raw data, train the model there, process the model there, or process the data there. And then, as I was mentioning earlier, so this is a visual representation of the upper and lower bounds. So this is just for one data point. So ultimately, there would be many of these various data points for each asset. So as, let's say, those RPMs go up, we expect, that top maximum value is actually going up as well, but it certainly exceeded that normal range that was determined by MicroAI. So whenever that range is exceeded, that's whenever those events are triggered and sent out for consumption. A couple screenshots at the platform. We have a free trial on the platform. You can certainly kind of click around and try it out. Again, a lot of existing dashboards and templatized dashboards to work with. You can also modify dashboards. So plenty of business intelligence tools out there. Here's another one for you.
So do you guys have a template of those dashboards that you can just say, hey, okay, I got the macro AI, I got the chip, I have sensors, I have the sensors connected to the chip, and that's then sending through a device up, and then you can connect each one of those sensors. Is it like a drag and drop platform, or do you have to, I mean, how do you use that?
Yeah, so everything you just said is yes. So early on in the slides kind of showed that device profile, the connectivity, your events, your notifications, the workflows, obviously the MicroAI aspect, which you can, if you obviously don't have MicroAI on that device, you can download from the repository, depending on which environment you're running it in. You can download that specific SDK to embed onto that device. Once it's there, then you can fire up the device and feed it into the platform for visualization, and then configure those events and alerts. So really, from start to finish, can all be handled within inside of the platform.
And does MicroAI determine what is a normal value for the different parameters, or multivariate parameters that work together?
Of course, yeah, that's
you don't
heart
set
and
that.
soul. Yeah, no. So it's all. So, and I guess I can go into a bit more detail on that. So it starts out as an unsupervised learning method. So we'll say let's fire up the training mode. It'll start consuming those data points, understanding what the behavior is during that training mode. Once you've switched out from training, more so in production, and those events start to go out, when those events are triggered, a subject matter expert, a technician, a business user can get that data snapshot, the data signature that actually triggered the alert, go inspect the machine and say, ah, yes, it was actually this, main bearing for this this vehicle that was going down. So the next time we see that same data signature, well, rather, they classify that data signature, and that's fed back into the model. So the next time that we see that same data signature, we can provide more intelligence to exactly what's happening to that particular asset. From there, what we're working on is really automating that corrective action. So by default, whenever there is a particular data signature that we've seen before, we've comprehended the action that was taken. If there is the possibility for automating that corrective action, that can be put in place as well.
Hey, Chris, this is Ricky. I've got a quick question here. Just more out of curiosity, but between the collection of your sensor and telemetry data and the initial modeling and testing, is there also any preparation for asset twins and the subcomponents? I know you touched on that, but I don't know if the digital twin sector is something that you guys are also providing.
Yeah, so ultimately we're not a digital twin tool. Siemens has a great digital twin tool. What the platform does is basically gives you a real-time look into what's happening with inside your facilities. Then you can also switch over to historical and start doing your, shift over shift or certain time frame analysis, horizontal analysis, vertical analysis. So you can kind of see that real-time look or historical look within inside of the tool. As far as, in the digital twin sense of, let's say, can I run this line at, a 5-second faster cycle time? Are there going to be any negative repercussions? Not something we've dipped our toes into yet. So digital twin probably isn't exactly what I'd label this, but certainly, you can get a real-time look into what's happening, get those alerts on, what's causing these issues.
No, and that's a great answer. I was just more out of curiosity. But the other, going on your last slide, what are the timelines? Let's say from, when you, I don't know if it was that one or the one before. I was just curious about the timelines when you look at the from that establishing the business case all the way through deployment. What kind of time are you looking at, in an either an ideal or a non-ideal environment?
Yeah, absolutely. And it's a good question, and it's really hard to pinpoint a time frame. We have customers that are just on top of documentation. They understand, well, one, they have their PLCs networked. They understand their PLC tags. If you have a sophisticated and well-organized client, it can be in a matter of that, 3 to 5 month time frame from initial conversation to, data's coming through that's and the output is at an accurate, 95% level. There's others that want to jump into predictive maintenance, yet they are running all of their maintenance logs through a paper and clipboard that's handwritten by the maintenance techs at the end of the week. So it really depends on the client.
No, that's excellent. Okay. No, thank you.
Yeah, absolutely.
Chris, one last question, and I promise I won't have more.
No, keep them coming. They're great.
Keep them coming.
Does your system actually send back commands to the PLC? So if something happens, do this. Or is it just monitoring that someone has to manually take action?
We have done that with, I believe it was a Lincoln Auto Access E controller or a welder. That's kind of that's the main one as far as tying back that corrective action to the controller. So it's on the roadmap to continue doing that, because ultimately that's the goal of IoT, right? I mean, IoT is a vehicle for data, and data is fun to look at on a screen for about 10 minutes, and then you realize, okay, what do I do with it? So you want that data to automate the action for you. Ultimately, I don't even want to look at a dashboard. I just want to know that everything's working well, because those actions are automated. So, long-term vision. We want to continue doing more and more of that, but only a handful of examples, the primary one being able to tie directly back to that, that welder controller that increased the voltage after so many hits.
Thanks, Chris.
Yeah, absolutely. All right. Right, so just bringing this back full circle. So there's the platform itself, production grade, high availability. This really allows for quick time to market to deploy those end-to-end solutions. That process of taking your device, creating that device profile, embedding AI, embedding MicroAI into that board, and seeing that data on the platform. We run workshops and people are able to do this in less than an hour. And that's from, unboxing a device, plugging in the IO, and embedding the MicroAI onto the board and seeing it on a dashboard. So very, very quick to get this up and running. Ultimately, it's streamlining a lot of complex business problems and really increasing productivity and OEE for these industrial deployments. Key elements here are, since we're able to train there locally, we're able to keep that data private and secure, right? You don't need to move that data from the four walls. So certainly a key element there. And then secondly is that, very small data and memory footprint. So one, you don't need an expensive device or piece of hardware to run this. And, if you're able to essentially run this on a legacy equipment. So you don't need to go out and buy new hardware to deploy an AI solution. Again, agnostic to the data, agnostic to the cloud, agnostic to the connectivity type as well. I think I probably just hit on a lot of these, but one other note on the on processing there locally. So with IoT devices that are battery operated, a big hit to the power consumption is actually connecting to the network and making that data communication transfer. So instead of sending all of that raw data that then needs to be processed elsewhere, keep that data local and only hit the network, which has that negative impact on the battery. Only make that data transmission when absolutely necessary. So certainly helps on these IoT deployments that are based on battery powered devices.
Yeah, you make a good point there. I know we had a lot of problems on our initial solution and that we kept draining the battery, which was not good when we had gen sets that were going out for rental. And by the time rental season came around, all their batteries were dead because the telematics device drained it.
Exactly. So I believe that is our last slide here.
I do have a question.
Yeah.
You didn't talk about it, but when I went out onto your website and I looked at some of your, so you have some pretty good information out there about how you can download and actually practice this and do some code. I didn't actually do the code, but I was just watching the video. They talked about a security. So one was about the AI, and AI doing, predictive analytics, right? But there was another packet out there, and it was about security. And so I was trying to think about security. And I know that on the telematics devices that we use, we actually had firmware. It's on the telematics device. And we had, at the platform, we also had security, and we had to, it was really important to make sure that the telematics device that was talking to the platform was truly our telematics device, and there wasn't a man in the middle or any of the other security issues that came up. And we did things like public and private keys to do that security. You guys, it looked like this was doing a AI software solution on security to determine based on how the device was operating, you could tell it was hacked. Can you
Correct.
tell me a little bit more about that?
Yeah, certainly. So the behavioral profile, whether it is, how is a robotic arm working, or how is a pump jack performing in the middle of nowhere, Texas, looking at, those physical components, your temperatures, your pressures, et cetera. So we can form a behavioral profile around those physical components. We can also form a behavioral profile around the IT or connected asset. So think of your computer or your cell phone or an IoT device that's out in the field. How those devices are used on a day-to-day basis has a pretty common behavioral profile, and very specifically in the IoT space, the behavioral profile for those devices is pretty static, right? It may wake up once an hour, send an 8 KB packets, and go back to sleep. So by looking at those internal data points, CPU usage, memory usage, data packet size, frequency, the endpoint IP that it's pointing the traffic to, maybe a root user logs in. So any abnormal behavior within inside of those various parameters internal to the device could be a sign of malicious intent. So it's really on the endpoint threat detection side. So instead of triggering a work order for a technician to fix a broken pump jack, you could trigger a security ticket to open up in the CISO suite. It could be that we cut network traffic to that device. We could call or send a command for that device to reset or reboot. So again, it's the same exact foundational element of MicroAI with that behavioral profile that's formed, but instead of the external parameters, really looking at those internal parameters of the device.
Would this be like another layer of security on top of the normal security with the public-private keys, or is this just a standalone on its own with the MicroAI?
It would be, an additional layer on top. Certainly additional layer on top. So you still, follow industry standards or go above industry standards with various, TLS encryptions and your public and private keys and all that good stuff. But devices are still being hacked, and a lot with zero-day attacks. I'm sure you guys remember. I guess this was 2-3 years ago. The big Stuxnet hack that went into a lot of IP-based cameras, and all of those IP cameras traffic was pointed to Netflix and Twitter servers. Jeff Bezos' phone was also hacked in a similar manner of a zero-day attack. So whenever those changes of behavior, right, specifically with those IP cameras, whenever that IP address, the endpoint IP address was changed, that's a significant change. So we could have picked up that alert or that deviation to normal behavior and automated that response to mitigate the catastrophic event that occurred.
So you could prevent a hostile government from causing your uranium separation centrifuges to run until they exploded.
Yeah, catastrophic maybe a bit much there, but you are exactly correct. I mean, I know exactly what you're talking about there. By looking at these small deviations and what's happening with those connected assets, could certainly at least be a forewarning to action that needs to be taken.
Okay, so what I'm getting out of this is smaller microchip, cheaper, right? Because it's on a smaller device. You still have to send the data back, so you probably need a gateway or something there, but you could maybe do it with a smaller cost solution. You're only sending back data as events are happening, as opposed to all the raw data, because you're doing all the AI locally at the device, at the edge. You're taking less battery power, and you have better security, or another layer of security on top of the normal security that's out there in the industry. I mean, it seems like a pretty good solution.
Well, thank you. Thank you very much. And yeah, spot on. And ultimately, the data doesn't necessarily have to leave. You know, if this is an on-prem deployment, obviously it can all stay within inside of those four walls of the facility. But yes, spot on.
Interesting. What other questions does anybody have? I know you guys have been great about asking questions as we've been going through the presentation. Does anybody have any other questions or discussions?
I got a question. So in terms of modeling, right? So so like the algorithms we have, so what kind of success rate in terms of like, I mean, are you like any false alarms or any outliers, and like how, I mean, because AI is not always 100% accurate all the time, right? So we have to keep ingesting, you know, new data as come in, and then kind of get adapt to those, you know, change the models and things like that. So I just wanted to know, you know, what your, you know, what you have seen with the clients in terms of like.
Yeah, certainly. So we run a confusion matrix to look at those false positives, false negatives, true positives, true negatives, to ensure that, you know, we are actually, well, rather, the last thing we want to be is the boy who cries wolf, right? Certainly don't want a lot of those false positives that are being sent out. So through that initial training phase, there's usually a little bit of additional feature engineering that goes in there. Think of tuning a carburetor, just making fine-tune adjustments to ensure that, you know, you're not sounding alarms when alarms should not be sounded. And depending on the client, there may be some instances where they would rather have more false positives than than missing events, right? So let them get all of the events, and they'll deploy the resources needed to ensure that it's actually not an issue, versus having such a high threshold that you may actually miss some true events that are occurring. So case by case deployment or situation there, but we do have a process, and it's through forming those confusion matrices.
Okay, great. Thank you.
Okay. Any other comments? All right, guys, I did go ahead and hit the record button. Sorry, I hit it a little bit late. But I will go ahead and put this recording out onto the IoT Peoria Meetup site. It's in the notes. You'll have to go to, when you go into the IoT Peoria Meetup, you'll hit past events, and it'll be in the comments. So there'll be a link there. I'll put that out within the next couple of days. I'm also gonna try to send it out through the LinkedIn as a message to say, hey, here's a recording and here's the link. Or you guys can, in a few days, go ahead and go to YouTube, and you can search on IoT Peoria, and you can look up OneTech.ai, and that should come up there also on YouTube. So I will go ahead and post this out there. I do want to thank Chris and Brad. You guys did a great job. I don't know if you looked at the comments. There's some emails in there. There is some good comments in there about the great presentation that you guys did. I really appreciate the information that you guys gave us. It was some great technology. I want to thank the participants who dialed in and all your great questions, because that's what really makes it fun as well, is just to make some new connections and to hear the different discussions, and for all of us to learn from one another. So I do have these once a month. I have somebody that is lined up for December. We'll do that probably the first or second week of December. So be looking for that out there as well. And you guys, thank you very much for attending, and come back. I'd love to have you guys back to another one.
Absolutely. We thank you guys very much.
Thank you.
Thank you much.
Everyone,
Thank
great
you.
initiative, guys.
Thank you,
Nice
guys.
meeting everyone. Bye.
Bye. Thank you.